in my own testing team, ever so often we'll pop into the Slack room. Oh, you got to check out this podcast of Brian. So really good content and focused mainly on the Python language, but really just testing and automation keys in general.
Hey, I'm really excited to be here. Awesome. So I'm not quite sure, I'll get into it a little bit. Testing strategy to increase developer efficiency and effectiveness. That's a really cool title. And I came up with what the talk was like last week. So I'm a little nervous, and when I get nervous, I talk fast. So I have no idea if I've got 20 minutes or really 90 minutes. But I was told that there's a break. A lot of the other breakout sessions happen at 2:15, and you're not going to offend me at all if there's something in the other session you want to go to halfway through. All the slides are online, and I think they're recording this, so you can see it. Or if you got something you want to do, there's other room. Anyway, I guess I'll just get started. This is the title, of course, but it also really is. This is what I'm really talking about. I am a developer, and I really care. The reason why I care about testing is I care about how to making sure my software works. And I also want to learn how it's working and how to develop it while I'm developing it. And I think tests make that happen. So that's this may be one of the things I'm worried about with this talk in this audience is most of the stuff that I'm talking about. If I know there's a lot of testers here, I don't know how many people are here that don't test. And the people I'm trying to convince are the development community, not really you guys. I think you're already doing the right thing. A little bit about me. A couple of years ago, I started. I'll fast forward a little bit, but I develop in C++ and embedded systems, and I test that code with Python. And the Python test frameworks were a little confusing for me, so I started writing about it, and that's where pythontesting.net came in. And then one of the other things that I know about myself is that I'm a little nervous about public speaking. So I started podcasting, and with the hope of eventually speaking at conferences. And this is number one, so. So I hope it goes well, and I listened to this morning's talk, and it was perfect for me. I'm the introvert that's trying to pretend to be extroverted. And as a day job, I work at Roden Schwartz. I've been there since 2010, and I really love. Is that happening when I'm breathing down? Anyway, I like it in Oregon, and so I came here mostly for Oregon. So it ran off the end, but that's my career basically. I started with a computer science degree at the University of Oregon, and then moved on. Now a computer science degree or a computer engineering degree at Oregon State may have helped me in my career at HP and Agilent better. Nothing against U of O. I really loved my time there. But I didn't take any electrical engineering classes, and when I jumped into satellite test and oscilloscopes and spec-ans and all that stuff, I was a little lost. And there's a pop-up. This Java update. Thanks, Java. Yeah, so the things I work on are what I think of as, I think everybody does. The reason why it's called engineering is because they're hard problems. They're complex systems. They might look like they're one box, but they're really multiple operating systems, multi-threaded, hardware and software interactions, There's no way to test just the software. This idea that you can mock all the hardware out, it doesn't work when you're testing this stuff. And another thing about it is it's all legacy code. Or I've never been on a project that didn't have at least some 10-year-old code in the system. So I was a programmer in hardware land and a little lost, and I didn't know what to do. So yeah, I was surrounded by a bunch of electrical engineers, specialists, and at the time when I entered HP doing tests, the manager I had a computer science degree, and he really wanted a whole bunch of other CSs there. And that was good, but the rest of the people I worked with were retreads. They were people that were electrical engineers that learned programming on the job. And the result of that was I had some serious imposter syndrome. I didn't think I belonged there. And I talked with my manager and I talked with other people about what to do about it, because I mean, even just to do my job, my first job was to write a driver for a phase noise system. And I didn't even know what a phase noise was. So I talked, my first supervisor said, maybe I should learn some RF concepts and start like training myself in electrical engineering. And he gave me this Horowitz book. If anybody's seen it, The Art of Electronics is, it's a big book, and it's 1,200 pages or more. And I tried, but that's not where my brain goes. So anyway, I just decided that was silly. I went through actually several managers that argued with me about this, and they tried to get me to learn more. But I just used the book as a monitor riser mostly. Instead, I talked with the people that knew what to do. I felt that the communication skills of learning my team and learning who was the specialist in what, and being interested in what they were doing, and just depending on them, being willing to ask questions. And that worked great, and I've been doing that ever since. So one of the things that came up, some managers were good with this, some others, and the important part was getting results done. And as long as I could talk with the engineers, the electrical engineers enough, and get the job done, everybody's happy. I'm going to fast forward a bit. When I started systems, went to microwave division, which was the spectrum analysis, which my mental model for a spectrum analyzer is fairly simple, but it's enough using comb filters and stuff. It's enough of a complex system that when I actually moved to oscilloscopes, I went, oh, it's just voltage over time. What a simple instrument. Wow, didn't go over well with my manager. But when I eventually got up, I was working on a communication tester in Spokane for Agilent. And I was working really closely with the FPGA engineers. And it was that time where this was maybe 2000, around that time. And FPGAs have a lot of registers. And I was writing the interface between the layer 1 code and the FPGA code, was doing the protocol stack. And it just was, it was hard. And there's I think I have some interesting stuff about that. Yeah, there's read-write registers, read-only registers, write-only registers. There's a whole bunch of stuff that you can do wrong in software to get it wrong, and we did those things. And I looked at the process and I said, well, how do we get these registers defined? And the FPGA team had their development process, but the output of that was kind of ugly, so they converted it to a spreadsheet, and they gave us a spreadsheet, and then we would sit there and look at the spreadsheet and type that stuff into our code. And yeah, that's just obviously bad now. So the solution, yeah, so there's obviously human error that I noticed with that had to be eliminated. The other thing I noticed was that these were hard to test. Read-only register is difficult to test. Write-only register is difficult to test. So I had enough time, I guess, to explore my options. And first, I wanted to fix the source of the errors, which were the people. So I looked into automating things and created, at the time I was reading Pragmatic Programmer, and there was reference to mini languages. And I looked at the output that they had, the FPGA team, and the input that I needed in my code, and realized that a computer could do that translation better than people could. So created, I don't know, took a week or so to create scripts to convert from one to the other. And there were other little subtle changes along the way that were mostly communication based. There was a problem with the way we talked about the hardware and the registers. The FPGA developers had certain names for their registers, but those names didn't match the naming convention of our software. So the names were changed, the capitalization was changed. We put underscores in places where they weren't supposed to be underscores, things like that. And that just caused confusion. We couldn't search for anything. So eliminating most of that. Now, there's also the case of how do we test it? And at the time, I was reading about test-driven development, and I really wanted to unit test. I'm like, man, the software industry is telling me unit test is going to save the world. But I can't get there. I've got an embedded system, and I did understand at the time that it was best to test in the system that it's going to be shipped in. I could have taken this code and put it on my desktop and tried to unit test that way, but I did feel like testing in the box is the best way. But the closest I could get was to convince the people doing the remote interface to give me a couple extra interface commands that I could fill in the blank and put anything I wanted in there to get down to my layer. And I used those to do subsystem testing. I basically called a remote command with a string, and that string, I had a little parser in my code that would pull that out, and I could run some tests inside. And I could control everything from my layer down and control the hardware, and it was great. And then I also thought, how about testing that stuff? I can mock the hardware completely, and that helped. This is memory. I was using memory mapped addressing for the FPGAs, and I could say, well, instead of the base address that the hardware guys gave me, I'll just create some RAM and put the base address somewhere else, and then I can fill in those addresses with stuff that I know about and test against that, and that worked great. And I was like, good quality. I was productive. What went wrong? What went wrong was I didn't know how to use the instrument. There was a program in the company called the Customer Touch Points or something creepy like that. But it was like trying to get engineers and everybody in the company to visit a customer at least once or twice a year. The goal was like once per quarter, but like, let's get real. So I went with a couple of marketing people, and they would be giving this talk great, by the way. But we went to Texas and Boston and a couple other places, and my job was simple. They were going to talk to everybody, and all I had to do was go and listen and run the demo. But I didn't know how to use the interface because all of my testing was done through my subsystem testing, and I didn't know how to use the interface. So I just sat and watched them do the demo. And from that point on, I decided that maybe there was a better way. Part of testing is learning about the system. Part of testing is learning how to be the customer, how to see your product like the customer sees it. And that was a lesson I needed to learn the hard way. But I think I'm going against the grain for software developers right now. There's still a large push to unit test only for developers. A lot of the other benefits of system level testing, you guys all know this. You're close to the customer requirements. That's how it has to work anyway. And there's a whole bunch. I realized also debugging. Pardon me for a minute. Debugging is hard. Debugging embedded systems and complicated systems is even harder. And I didn't have any problems that I spent days trying to solve that were isolated to one file. They were all, it looks like the error's here, but it's really over there. Or the layer 1 code thought the interface was doing this because that's the name of the function, but we really were doing something else at the lower layer. Bad communication, interactions between systems. Timing problems are terrible. Timing problems actually always still plague me. And the biggest one is that I get is if in instrumentation we often build twice. We build a debug build and we build a release build. And the debug build has stuff like debug flags and just so everything, the code's laid out well. The release build has all the debug flags pulled out and it has optimization turned on. And if you were going to step through it with the debugger, it's a little harder to do because you jump around and stuff. And issues that come up are that are terrible are when it's a bug that exhibits itself in the release build but not in the debug build. Or vice versa. I've had times where I've had to convince people that a bug is okay in the debug build because when we compile the release build, it doesn't show up. Anyway, I'm sold on system tests, and I have a hard time having anybody convince me otherwise. What do I got left? Oh, by the way, the actual topic of the talk of how to increase developer efficiency and effectiveness, that's like 20 minutes. So I'm telling this long story to try to fill up the rest of the time. The different levels are definitely important. And over the last, so I got sold on testing in around 2010. I've been doing it for, 2000. It's been 16 years. It's been a long time. But the way to do it, the different levels are definitely important. And I think of them, there's a lot of names, but I think of them as the tracer bullet or happy path tests. And this is what developers do. And if you read test-driven development or anything, they'll say the first step is write a failing test. How? And with the test that a developer will come up with will be to just test the functionality that they want to develop. Great, but that's kind of like if all the stars line up correctly, this will work. But then they can go on and move on to other things. Now, experienced developers, of course, move past that and look up error conditions. But there's problems. But the overall, I think happy path tests through the system and with good functional coverage for the system level. And but fine-tooth subsystem tests definitely are important. Like I work a lot with measurement technology with DSP engineers. And one of the issues is the DSP guy is like booked, or girl, they're definitely non-PC. Okay, the person doing the DSP, they're booked. They've got projects lined up, and today they're working on my project, but tomorrow they're going to be working on something else. So we do need to get like as much coverage as we can when they're working on it. And then, but you can't go all the way to the user interface for that because you don't have it yet. So definitely there are cases for subsystem testing. So that little story about reading pragmatic and doing automation with the FPGA registers led me to start reading about extreme programming, test-driven development, test-first programming, and such. What do I have next? So couple influential books that I read. Definitely, if you were doing any development, I believe these two are very, very good. Pragmatic Programmer and Lean Software Development. They're both aged a little bit, so there's a few things in there that are dated. But I'm going to go through some of the things I learned from these. And yeah, by the way, at the beginning of the slide, I did note I pushed all this up to my website, so It's at PSNQC, did I get that right? PSNQC 2016.pythontesting.net has these slides. I want to go back a little bit. I started with extreme programming, but I got mad at it, and it frustrated me because it said lean practices, and not lean, agile practices and things like XP work best for small teams with new code bases and well-defined projects. I didn't work on any of those. I worked on really big projects that had been around for a long time, had functionality that was in the system forever. There were known problems. There are known chunks of code that we knew were problematic, but nobody used it, so it was okay. Or there's definitely the biggest problem I have with legacy systems isn't that there aren't tests for it, because if it's a legacy system, your customers are testing it, so there are tests. The problem I have is pieces of code where somebody says, don't touch it, it works, and we don't know how it works. So the advice to take a legacy system and put tests around it, those pieces I agree with. I agree if you say, don't touch it because it works and nobody knows how it works, put tests around it, and then you can refactor it, hopefully. But it's a cost-benefit thing. So the first thing I ran across was when I was trying to learn about stuff was Ward Cunningham. He's a Portland guy, so that's cool. He had made the Portland pattern repository, and it's called the C2 Wiki. And I'm going to pull up a screenshot that I did, but I had to go back in time into the Wayback Machine or something to grab it because it's currently offline. It's a bummer. So this is my introduction to test-driven development that I learned and loved from the beginning. Right now, TDD is called Red-Green Refactor. At first, it had more steps. And I'm going to highlight a couple of them. My favorites are these statements. Think about what you want to do. Think about how to test it. And then at the bottom, please note the first items is by far the most difficult, followed by the second item. But if you can't do these, you probably shouldn't start writing any code. The rest of the list is really pretty easy. I don't agree with that. But the first two are critical. I do agree with that. Think about what you want to do and think about how to test it. You need to, as a company, as a division or whatever you're in, you have to figure out what you're going to make and sell. But you also have to know how to make sure it works. And that's way more important than how are you going to make it work. You clearly have to make it work. But if you can't know if it works, then it doesn't matter if it works or not because you can't prove it. I'm not going to read through all these, but Pragmatic Programmer is still an incredible book. I try to read it about every 5 years. And these are just a handful of things I got out of it. Like I said, the code generators were great. Plus, if you want to have like a little extra project in your work where you're like working on something that's just fun, tell your manager that you're working on a mini language implementation to solve one of your critical problems with your processes. Sounds good. The other one, I read tons, but these two books really stood out. Lean Software Development. This is the lean way of thinking of looking at your processes and looking at what you do every day and deciding whether it's adding value to the customer. Not adding value to your manager, not adding value to somewhere else, adding value to the customer. Are you making the product better? Are you making the customer more happy with what you're doing with this step? Is this report that you have to fill out really important? It's actually one of the reasons why I have a problem with pieces of Scrum right now, because I don't really know how putting points on my stories helps the customer. But that's a different talk. Yeah, if you do go out and read Lean Software Development, I recommend take to heart the the introduction in chapter 1, the chapter 1 talks about waste and looking at waste in your system. Then they come up with a bunch of tools that are things that we do, but they have their own names. Like Kanban's in there, but it's called something else, and I don't know. So I think they kind of went off I think maybe they needed a 200-page book and they only had 50 pages, so they filled out the rest with the tools. I'm not sure what happened, but the first bit on the principles is worth the money. So my own philosophy for how to test in development came from a mesh between all of those. It's things from TDD and pragmatic and lean. I want to develop tests that give the most value and confidence. So I want to be confident in what I was shipping. But I also want to develop software in a smart way because I know I'm not good at it. I know I'm going to get it wrong. I know everybody's going to get it wrong the first time. So I want to allow for that. Allow yourself time to learn from the system. I mean, everybody involved, from the tester to developers, the FPGA guys, or whoever, they're going to learn how the software works, and the people they are at the end of the project are way better people to implement this piece of software than the ones that started at the beginning. So second drafts are important. The write-up for the talk we said we all know the benefits of automated testing, and I don't know if we do. And maybe we do, but I disagree with some. So the benefits I really care about are that the software behaves functionally correct, that it works. I want also to, during development and testing, to develop the best APIs possible. And of course, the way to do that is with the system level tests and or whatever module you're using. The API for that, writing tests for it is a great way to test your API. I know that you guys have used APIs that are silly, that clearly the developers didn't use them themselves because they don't make sense at all. The developers should be using the API. I also want to write less code. And by less code, I mean less test code also. I want to only write test code that adds value, that tells me something about the system that I didn't know before. And the source code too. I'll talk about that in a little bit, but the software developers are kind of funny people. And at least the ones I know, once they understand a problem, they're perfectionists, man. They'll want to just sit there and churn and make it perfect and refactor it, and they don't. This idea of testing to tell you when you're done and move on needs to be applied at multiple levels. And there's a lot of people doing a lot of fine tuning when they don't need to be. I care a lot about learning and discovering requirements while I'm during development. And I want to apply that. Confidence in the system, of course. I want the refactor thing. The TDD push and unit tests are pushed that developers should be able to refactor without fear. I agree with that, but I just don't think unit tests give them that. If they're not afraid to break the system because the unit tests pass, they should be afraid, because it's not telling them that their system works. It usually tells them that they've changed the algorithm in such a way that it's the same understanding they had before. It's definitely good. It's not bad, but it's not everything. Refactor with less fear, pride in your work, and more free time. That's where the efficiency part comes in. Whatever I can do to get developers to have time at the end to say, you know what, we're done early, and I didn't like that algorithm. It was ugly. I mean, every development team I've been on has a list of things that they wish they could fix. Things that they don't really matter, but they do matter, but they work, but they're not proud of them. And I want developers to have time to go back and make the software something they're proud of. And I think it's important. But it is a cost-benefit situation. If you're going to cancel the project, that's a bad time to refactor the code. But if you know we're making a lot of money off of it, and this guy's going to have to live with this library for another 6 years, he should like it. He should be happy with it. And giving him enough time to refactor is a good thing. The ability to make late implementation decisions. This is from the lean methodology, of course, but this notion of use your tests to decide if you're functionally doing the right thing. If your software is working, then great, but it might work really ugly under the hood, and allow yourself to make it better. There's other stuff that's touted as benefits of testing that I don't really care about. Better implementation design. We design better with tests. Okay, but I don't think that we need to get it right the first time. I don't care about getting it right the first time. Modularity. I know it's good. Solid architecture. I always forget what that means. Yeah, I don't remember at all. But you'll hear developers talking about solid architecture, but do your customers care about the modularity of the libraries in the code? They don't. It's not adding value. So if that's a side effect, great, but it's not really a value. The thing that I put them in as benefits, and some people think of them as benefits, things like change detectors and roadblocks for future redesign. There are developers that are really touchy about their code and they don't want anybody to mess with it. And they would like tests in place to make sure nobody messes with it. But if the functionality is the same, if the behavior works, if you redesign it, your test shouldn't fail. A failure at that point is a failure in the tests. And so that's tricky. It's tricky to write unit tests at a very small scale that don't break when you redesign something. So that would be, I'll probably get to that in costs. So benefits, costs of testing, of course, development and maintenance costs. Yeah, we've all been there. I was on a project where there was a whole bunch of managers that every week would look at a graph for number of tests and number of tests passed. And they just wanted to see that go up. So it was really hard. It was really easy to satisfy that. Just write smaller tests and redundant tests. But then you have to, great, they were happy, but they didn't realize that later it's more code. I mean, we realize that. I don't know why we don't realize that with tests. We realize it with source code. We know that 1,000 lines of source code is easier to maintain than 5,000 lines of source code. But 1,000 tests is easier to maintain than 5,000 tests. If you don't need 5,000 tests, don't write 5,000 tests. It's a maintenance issue. False positives and negatives, that's part of the maintenance cost. If tests fail, when the system still works fine, you gotta prove to yourself that it's really a test, not the system. Oh yeah, I'm gonna go on a rant. The bottom one is brittle tests. When I do talk about the cost of testing, a lot of people that I've talked to said, yeah, man, like there's this test that like it just fails all the time, and we just ignore it now, or we're gonna delete it because I don't. Why do you have tests in their system like that? Why, if the anyway, so the thing I'm really getting at is that this is often an argument against system level tests because they break, and I do understand that it's very difficult to write GUI tests with graphic interfaces or even web interfaces that are robust, that you don't have to change a lot. And maybe you need, I don't do that. I do know that Selenium is solving some of those issues. It's getting easier than it used to be. But at the same time, whatever API your customers are using, that's what they're using. You should test there. And if it takes a customer procedure a long ways, if you've got a test that's really big, and it's big because that's what the customer has to do, you've made them do this long process, it better keep working. If that test fails, it's just as good as a customer failing their test. So that was my rant about brittle system tests. And I was just getting thirsty. It usually is a longer rant. There are some costs particular to unit tests that I don't like. And I talked about some of those already, the change detectors. A test should not fail just because you change the code. If the behavior is the same, the test should pass. If it doesn't, it's a bad test. But the more of it is I do see the behavior of developers when they are too dependent on unit tests. And part of it's the teaching. The test-driven development, it's a cycle. You write a failing test, you write code to make it pass, you refactor, you continue. Refactoring's fun, and I can get away with it because the TDD says I get to do it every iteration. And then I go back, but then there's this, well, when do I stop? When is my job done? And sometimes the answer, I don't agree with this, but sometimes the answer to people is, you stop when you can't think of any more tests to write. Engineers are really clever, and they can come up with a lot of tests to write. And I think that it designs the heck out of some things that's unnecessary. And you can defend yourself and say, it's necessary because my test failed, so I need this extra feature. I need to be able to deal with very large numbers or very small numbers. That's, I don't know. I still think it's kind of like I need to make sure that my nails are perfect to make sure my house is okay. I don't get it. Yak shaving, bike shedding, these terms that I just like because they're fun. I don't even know if it applies to this, but it does apply to how developers work. So, and swamp draining. I just learned this recently, so I got to share that. So yak shaving. It's interesting. It's kind of little detailed work that is around the thing that you have to do. And I think of unit testing as that, as people playing with code and they think they have to because it's important for their work. And the definitions are interesting because it could be that it is, but it could be that it isn't. It could be that you're just doing extra work for the heck of it. Bike shedding, it's procrastination and over-designing something. And a lot of times I talk to people about why they're not doing system-level tests. And the argument is because they're slow. But when I dig deeper, it isn't because they're slow. It's because system-level tests are hard to write. It's hard to think about how to test the system at a system level. Unit testing is a lot easier. I don't have to care about the state of the system. I just have to care about the state that matters to this little function. But it's hard is a really bad reason to not do something. These people are paid to be engineers, work on hard stuff. It's okay that it's hard. Figure it out. I love this. One of the guys I hired brought this term to my attention, and it's, and I always forget it, so I'm going to go ahead and read it. When you're up to your neck in alligators, it's hard to remember that your initial objective was to drain the swamp. And I like that, and it applies to testing, I think, partly because you can run down and test all the little tiny features of your system and forget that the software doesn't work. It doesn't matter that your unit tests pass. The system doesn't work. You're focusing on the wrong thing. How are we on time? So in a few minutes, I guess it's the break time. I'm not done yet, which is good. I thought it was going to be like a 20-minute talk. So my I'm finally to the topic of my talk, and And I just finished the slides like 20 minutes ago, so I can't remember what the next slide is. Just a sec. Yeah, we'll cover it a little bit, and I'll just ramble a bit until we get to the 3-minute mark. I think that iterations per feature are important. And I was actually, to get ready for this talk, I watched a whole bunch of old presentations. And there was one guy who was here last year, maybe it was the year before, I'm not sure. But he talked about how there was one company that said they would do government contracts, and they would say, you can have the contract, but we're going to pay you 25% of the money. And you can get if you can get 25% of the system done in 25% of the time. Awesome. We should do our software like that. We should all do our software like that. Let's get features done 100%, like as if we can, one at a time, like knock them down. That's great. Tracer bullet testing and implementation. I'll talk about that a little bit. Partition boundary testing, which is partition equivalence partitioning and boundary analysis kind of shoved together. System tests and unique selling proposition subsystem tests and unit tests, of course. And then I've got some opinions about mocks and stubs. And then also, I think testing using the same tools everywhere. So that's my philosophy in a nutshell, and I'll walk through it a little bit, all the pieces. And then I also want to, one of the things that my beef against XP was for them to say, this is the ideal team to use it for. And I don't think anybody lives in the ideal team. So I do want to talk about how I think you should integrate testing into a life cycle of software, and how that can be changed for different teams, because I've been on lots of different teams. And now I'm going to let you guys, if anybody wants to, take a 5-minute break, because this is about the time where people are switching. If you want to switch to another conference, that's fine. Yeah, I'm probably not going to, I was told the slides, I'm on slide 39 of 56, so I probably won't take up the entire 45 minutes. But I'm glad, because I don't get to interact with people that test a lot, and I'd like to be able, I definitely want you to think of questions. So I'm going to go through a lot of the points of my strategy that I think might work, but I want you to poke holes in it, and I want to talk about it at the end. We can see how we can make this better. Yeah, actually, that was one of the things I was thinking about yesterday when I was polishing this. Polish, interesting use of the word. But I think of one of the analogies for writing software is it's like writing anything, like writing a novel. And I'm working on a book right now, and I'm working with an editor, and I am like astounded how much more I understand the information after I've written it once. I've talked with the editor. We've made the second iteration, more changes, and the third, it's pretty darn good. After we've done 3 passes through some writing, 1, it reads pretty well, and 2, I really understand it well. And I really believe in this message of trying to do more system level testing at the developer level. So I'm hoping to give this talk many times. So this is the first draft, and you can help me make it better. We talked about this a little bit already, iterations per feature. I do like that 25% of the system done in 25% of the time. That's awesome. But it's also continuous learning. It doesn't always work. You've got like, the kind of projects I work on, they've already shipped. We're already making money off of them. And they're new features. We've got a new iteration coming out, new feature coming out. And or they're fixes, or there's extra little bits that are added to the interface. And they don't come, I'm not sure, I know it's different in every industry, but I don't work in an industry where we can do continuous delivery. even if we could get a release out every week or every day, our customers wouldn't want it. It's just too much work. So we're shooting for usually 3 or 4, about 4 releases a year. If we could release quarterly, it's great. But the issue with that is you don't get one feature. You don't release one feature at a time. You bundle a whole bunch of them up. But if you do work on, instead of getting at 90% of the time, you don't want all of your features 90% of the way done, because you really don't know how long 10% is. But if you've got 90% of the features done, you can just ship today if you needed to and do the other 10% of the features later. So I do like that. And I do like this learning for each one. And actually just think of the rest of what I'm talking about on a per feature basis, not on a per software project. Tracer bullets, I got that from the pragmatic programmers, and it's sometimes called skeleton code instead. And that is what I think of as from the happy path, from the user interface or the remote interface all the way down to hardware. Get some feature working all the way down to hardware. And this helps amazingly. And this doesn't include just software and user interface. I want the person doing the user interface involved. I want the person doing the remote interface involved. It solidifies all of those communication requirements across the team as well to make sure that we can deliver a piece of software that goes all the way through the system. And it's a build process, making sure that if you're firing up, if you're going to do a new Jenkins server or something like that for the release, it's getting all of that done. And also, we can get started. We can branch out. I work on teams that are big, so there's a lot of fan out, and it's frustrating when you have to wait for everybody else to do their work before you can get started on yours. But if you've got to cut all the way through the system from top to bottom, then there's teams that can start working on other features. They can branch out, but they know the system as a whole works. Skeleton tests first as well. The API may suck at first. It probably does. Whatever you came up with, you won't know until you've started testing with it. You started writing tests and you realize it's clunky. And you don't want to have to go, let's say I did the test first thing and doing something wrong. I wrote all the tests first. And then I decided the API was wrong and wanted to change the API. Then I need to change all the tests. I want to write just enough tests to understand the API and learn from it. And then I don't have as much to rewrite. I think this is also a great place for coverage analysis. I'm not usually a fan of coverage analysis, but it's a great way to keep people from writing too much. At least, actually, I haven't even used it for this, but it's a theory of saying, hey, we need cuts all the way through and do coverage analysis and realize that there's some component in the middle that's only got 2% coverage. You can go in and realize that maybe they over-designed that piece just a little bit. And then this is the mashup of equivalence partitioning and boundary value analysis. And maybe you guys probably know of it. Maybe there's good descriptions of these, of equivalence partitioning and boundary value, but I still can't find any. The Wikipedia article's okay, but it's not that hard when you think about it. And I like to think in terms of, it's the terms from BDD, the behavior-driven development? It's given, when, then. That's how I think of my tests. Given a certain state of the system, when I do some action, then something happens and I can test that. Now, all of those have big sets that they belong to. There's the current state of the system. What happens if I do that action in a different state? Does it do something different? So all of the different states of a system that are relevant to this behavior, keep track of those. the different actions you can do, of course, and then for a particular function, all of the inputs, you can do equivalence sets for the different inputs and come up with a model for how to test that. And this is a great place to fan out and test everything. This is after you've done a skeleton cut through the system, of course. But one of the problems when you do this is if you don't have the code implemented yet, is you'll get a whole bunch of failures. And of course, because you haven't implemented the code yet. You've just done a skeleton implementation, all the boundaries and the different exception cases and what happens if your server's dead, and you won't deal with those correctly. So you get to decide what you're supposed to do. And that's part of what I think testing is for, is to decide what you're supposed to do. What is the action? How is it supposed to behave in this situation? And that, I guess I'll jump ahead a lot. The reason why I've got Pytest stickers on my laptop and that I love Pytest so much is it's one of the few test frameworks that I've found that allows you to mark tests as expected to fail. And it does it dynamically as well. You can mark tests to be, if you're writing tests, it's very important when I'm writing tests to be able to say, I just want one code base of tests that I can use on all releases. So I need to be able to say, hey, this test, it doesn't even apply to version 4 because we implemented that feature in version 5. So to be able to have dynamically run a test and have itself know, hey, I don't even need to run right now because I'm testing version 4 of the software, so you can skip this test. And then expected failures are put in place as well to say, we know this is going to fail. The flip side of expected failures is expected passes, which is a little weird to think about, but it's the name they came up with for, I expected it to fail, but it passed anyway. And those are flagged as well as something different. You need to, and I use them lockstep. We develop tests, we expect them to fail at first. As they pass, we make sure that they really passed and didn't just, something's wrong and we faked it. But we did really intend to fix that implementation. And then we can take those flags away and not expect the test to fail anymore. Oh yeah, boundary analysis. So boundary analysis is often different. It's talked about different, and it's like if I have a function that takes a floating point, I should test 0, 1, -1, negative numbers, positive numbers, really big numbers, really small numbers. And I just take that to the same thing with the boundary value analysis. And when I look at for sets of states of the system that I have to test, you can think of the boundaries of those states, and I want to test the boundaries of the equivalence partitions. Working with this has always been very important to me when working with hardware, because as I treat testing, even system level testing, always at a white box level. I always want to talk to engineers that know what they're doing to tell me where I need to test. A simple example of that is when testing level setting. So I've got a let's see, when I was working on oscilloscopes, you've got different levels you want to set your, no, it wasn't, anyway. One of the things I worked on had level setting where like attenuators would click in. And at certain points, it wasn't in the manual where they were going to click in, but at certain points of the levels, attenuators would flip to have different routes through the system. Those attenuator flip points, we need to know where those are, and we need to test just above and below those. And those are good equivalence partitions, but they're not obvious from the manual. You got to talk with the engineers to figure those out. But you need to know that they work. You really can't have sets of, this one attenuator setting isn't working. You just can't have that. So it's important to, especially with hardware, to talk with engineers. Yeah, a good mix of system level tests mostly, subsystem where we need it, and unit tests when absolutely necessary. I really do think unit tests shouldn't be the bulk of the test. They should be like when you absolutely have to. However, I also kind of think of it like it's a design decision. In a lot of, there are some people that say test-driven development isn't test-driven development, it's test-driven design. It's how we design our software. It isn't about quality, which like, I'm like, what the heck? Your tests aren't about quality? What are you writing them for then? But if a developer wants to write unit tests to influence their design, I don't care, go for it. If it makes you write software faster, do it. But keep them out of my suite. I don't want your design tests to be in the entire suite of tests, because if we decide to change the design and your tests fail, that's not a failure, that's just your design changed. But if they help people write more tests or more software faster, great. There's, yeah, mocks and stubs. This is a tricky subject. You can test software a lot faster if you don't have to depend on anything. If you have a, especially with hardware, if you cut out the hardware, your software runs a lot faster, but what are you testing? For me, it's not an option. For we're doing hardware software stuff with test instruments, I need the hardware. So I've had to say, like I've heard, your suite, your entire system suite should run in 2 minutes or less. And I got 24 hours in a day. I'm okay with it being 24 hours. It's usually not. I've never had a test suite that took more than a couple hours. When it edged up to 2 hours, I got another box and we ran it in parallel and we cut it down to an hour. Cool, it cut my test time in half. But throwing the hardware at it is fine for me. There is definitely a place for it though. One of the, of course, I'm often using transmitters and receivers, and I apologize that I'm using a lot of RF terminology, but that's my world, that's what I know. To test a receiver, the world is noisy. Devices are flaky. So how do I tell if my receiver tests are working right, or my receiver measurements? Well, I put a known good signal. So the test equipment world has come up with generators, so we can generate signals that we know. So that's what we use. We use an arbitrary waveform generator a lot and generate a known signal. Now I can measure one end. So what I really wanted, I'm selling a box that like say tests a cell phone. I don't actually test my box against a cell phone, I test it against a generator. And the transmitter, we do that too. We have other pieces of equipment that measure signals, so I can test the downlink side against one of those. Works great. But it's also important to actually stick a cell phone in once in a while to make sure it works the entire loop. Mocking, but usually when people are, that's testing against known good data, and that's reasonable. And databases are like that too. We do tests against a known database. Like if I want to test to see if it's okay if I put a customer, if two customers have the same name, that should work. We should test that. But you might not actually have two customers, so you got to have some dummy data. That's fine. That's completely reasonable. The mocking though, there's a unit test philosophy that says you should only test the thing that the function or the class that you're working on, and you should completely isolate everything around it. And I completely disagree, and I find no use for that ever. That seems like a maintenance nightmare to me, to make sure that the mocks stay the same interface as the rest of the system at all times. That's just like, God, quadrupling your work. I don't want to do that. There's this idea that system level tests should be something different than the things the test developers use. And being a developer, I kind of don't like that, because I want to be able to use it. Because if the test breaks, you're going to ask one of the developers to fix it. The developers should be able to run the test. And if the developers and the test team are using the same tools, it's easier. I think that's the way it should be. But I don't really think, I think having a test team is way better than not, but I don't think the team should be separate. My ideal is it's a team, and some of the people are doing testing, some of the people are doing developing, or they're all the same, and sometimes they're doing testing, sometimes they're doing developing. In BDD, there's this, in like things like Cucumber and Gherkin, there's this language-based testing where you're supposed to like write use cases in English and then write code that translates that English into actual code to run it. And I'm thinking just like write the code instead of the translation part. I don't get that. But the argument is that your stakeholders will be able to write their tests. Anybody have any stakeholders that would write tests? I just don't buy the argument. So, yeah. I don't really know what the word stakeholder means anyway. I like wordplay a little bit, and I always, whenever I hear stakeholder, I imagine a waiter looking for whoever ordered the steak. Anyway, I don't think that we should design a test philosophy that ignores the rest of the tools that we have at hand. We have continuous integration servers. We have, and I'm going to come back to the multi-branch thing in a little bit. We have continuous delivery pipelines, which are awesome. So I don't do continuous delivery, but I use these tools because I can run the 10-minute tests right away and get those results to the team. And then after that, I can run the tests that take 2 hours and get those results to the team. And I can use continuous delivery tools to use that, to make use of that pipeline, even if I only deliver every 3 months. Multi-branch is something that is cool. And I didn't even know about it until it's one of the benefits of having a podcast is you get to interview people that you wouldn't have been able to talk to otherwise. I talked with Josh Calderemus, I think I'm going to get this right, Josh Calderemus. He's one of the guys that started Travis CI. And I didn't even know Travis did this. So how Travis, the continuous integration is like somebody checks in some code and you suddenly, you go test it all. But the Travis has this cool feature that it's on pull requests. So there's a problem that open source people have is you've got a whole bunch of people offering to fix your code and it might not work. So the Travis solution is to take those pull requests, pretend you did the merge, actually do it, but do it in like an isolated little sandbox, and then run all the tests there. And if it's good, then you notify the owner of the project that it's good. And you can do that on multiple branches. So it doesn't matter how many people have branched your code. They can all be tested independently, and that's cool. I don't implement that on my team right now, but I'd like to. The continuous delivery pipeline. Oh, revision control systems and code reviews. These have maybe they've been there a long time, but we've just started using code review tools the last couple of years. These online things to where we don't have to sit in the same room. The developers we can issue a code review, and we can all sit whenever we're not doing other stuff and check everybody else's code. I love them, and I don't even care if they come up with anything. We do them for everything on our team, and it is partly to catch errors, but it's also partly the big benefit I get is everybody knows what everybody else is working on. And then we can have, and a lot of stuff comes out of it that doesn't go through the code review tool. You can do little comments in the side to say, hey, maybe you could, the spacing is weird, or camel case, really? Stuff like that. But those often actually come out in the hallway. Somebody will actually send an email or just say, hey, I was doing that code review and it is correct. It's kind of ugly code though. You okay with me taking a look at it and reworking it? And I love those conversations. And revision control, I mean, how did we live without revision control? Well, when I started, we had, at HP, we used RCS. Anybody used RCS? And I don't even, it was like revision control in a directory or a file. It was like all local. It was horrible. But what we have now is great. And one of the arguments for isolated unit tests is when a test fails, you know where it broke because it's isolated to that unit. My argument is I know where the code broke. It's the stuff that got checked in between the time the test passed and the time the test failed. It's not that hard anymore with revision control. Wow, we're already here. It should be obvious, if not, it might not be obvious that I do have a coherent idea of how testing should be done. But it should be obvious if you understand it at all that it's easy to modify. So we've got some of the things that I've seen that are different between teams is the different system architectures and development team geography. Geography, why would that matter? I've worked with teams where the DSP guy is in Singapore or Sweden or somewhere far away. Or you've got I've got like 4 layers of software and 3 of them are developed here, but one of them's developed in Munich. These things are obviously interfaces of your system. And although I really like people to test mostly at the user interface, it definitely makes sense to test at the interface between geographically dislocated teams because you just want to be able to say, my code works and the other team can pick it up. Just don't forget the system level tests. System architecture, of course, obviously changes the way your testing works. If you're not dependent on hardware too much, then you're not dependent on hardware. QA or not, I'm sure it's probably all of you guys work on teams with QA teams, but there are a lot of development teams that don't have QA anymore, or have one person for 10 people, or it's a weird mix. And I was thinking about this and how I'd like, because if we have somebody different do the testing, then the learning doesn't go to the engineering team. I think the engineering team needs to be involved, at least in the skeleton part, the part to dive down into seeing what the API should look like, how to write the initial tests. Now, it definitely makes sense at this point that I think the fan out of doing the equivalence partitioning, the boundary analysis, and there's more. I mean, all the tools you guys know about of like state diagrams and table-driven testing and all those things. There's QA people that are better at that than developers are, and that's a great place to have a larger team jump in. So that's my opinion where QA would work great. Yeah, the GUI API subcutaneous interfaces and adapters. I work with things that have an API. In test instruments, it's called it's called Skippy. I don't even remember what it stands for, but it's a text-based API that our customers use to drive the box, and I can use it to test the box. But what about other stuff? I mean, a lot of stuff is just user interface only or web interface, and I still think that I've looked at some of the most successful web stories are things that have an API anyway. I think Twitter would be successful even without an API, but they do have a complete API. And I think it's partly because they can. It's there, it makes them more solid, and they can expose it to other people also. And I don't think there's any reason to not stick one in even if there's not one there. Even if you're not giving it away to the customer, having an API just below the user interface, why not? It'll make your software better. Which test framework you use, of course, determines a lot. This doesn't need to be modified by the team, but I needed to put this piece of information somewhere because I like Pytest and I wanted to talk about it. I brought it up already. One of the things that I like about Pytest so I could have developed the test frame. We could do testing in anything. I chose Python. I like writing in Python. And Pytest is darn cool for a lot of reasons. The fixture mechanism is a first-class citizen, whatever that means. They don't even talk about it like that. But it's really important to Pytest that fixtures be like awesome. And fixtures are set up and tear down. The way you get your system into the state it needs to be to do the feature, and you're going to run the test. That part is set up. That part shouldn't fail your test. The thing that you're testing is afterwards. And having the ability to make that part, the getting ready for, the given part, not fail to do something else, Pytest does that. It shows up as an error instead. And I love that. Fixture scoping. I can have setup and tear down around the entire session. I could have it a test session. I could do one thing at the beginning of the session and one thing and clean up at the end. I can do it around a module of tests. I can do it around a class of tests. I can do it around every function. All the scoping is there. I didn't know I needed 3 levels of scoping, but apparently I do, because I had 2 levels of scoping and it wasn't enough. I guess one of the reasons why I care so much about fixtures is because setup is a hard thing with hardware. And it takes a long time. And I want to, if I'm like bringing up, if I've got a signal generator that I'm generating something and I'm measuring everything, at that point, if there's like 19 things I could test, I should go ahead and test all 19 things. And Pytest allows you to group. It does group running. So if 19 tests have the same fixture, it'll get to that point, run those 19 tests, and then clean up. And it saves me a ton of time. I'm going to tell a story. I made this up yesterday, talking about how why fixtures are important and how grouping of testing is important. So if you're my neighbor, say, actually you're not my neighbor, you're my coworker, say, but we live pretty close. We live 10 minutes away from each other. And I'm going to go on vacation. I'd like you to come by once a day and check on my cat, check on the plants, bring my mail in. And I start listing off the things that I'd like you to do while you come over and check on my house. And you stop me and say, what? Oh, so I only got an hour lunch. I can't do all those things, because if I drive to your house and check the mail and then go home, or go back to work, and then go back to your house and check on the cat and then go back home, clearly you're not going to do all that. You're going to do all the things at once. What else does it do? It's really easy to learn. It can do the skips and fails, and this turns out to be the plug part of the presentation, because I've got a book about Pytest, and so that's why I'm talking about it. There's a current book that all of the content right now is free, but I sell it for the heck of it as an ebook, and because of that, I was lucky enough to get on with a publisher. So working with a publisher to try to get a Pytest book out. And one moment. One of the things I love is the development team. It's centered in Munich, but they're really all over the place. There's people in Brazil working on it. It's not a big team, but they're really responsive. And when I was writing the draft for this new book, I got to the part of like module setup. And there's one of the things you can write is setup module. I got it wrong. It's setup module and teardown module. 2 functions you can write so that when your test code gets in there, it calls that code. When it's done, it calls teardown. It's great, but it had a parameter called request object, and you had to give it the request object, and you can get cool stuff. You can get like what module was run and information about the test suite at the time. There's good information there, but it's hard to teach that because at first you don't need it. If you don't need it, I shouldn't have to put the parameter in. So I just requested to these guys. I said, can we make that optional? And it was a day. They changed the code in 2 days, and they made that optional. So now it's easier to write my book. And we got a little time left. Questions welcome. And that's how you get a hold of me if you want.
I don't need the microphone. I think everybody can hear me. First question, when you're talking about continuous integration, the one thing I'm looking at that is that we're the same thing. We don't deliver to our customer continuously, but can you look at continuous integration as being continuous integration between the development team and the software testing?
Well, yeah.
Because that's what we're doing, and that the same things seem to apply. It seems like what you're talking about is that each time you get a new feature, you do continuous integration and kind of continue from there.
And we do it within sub-teams as well. So we've using, I think, the development team all working on the same project. We've got, even though it's just one floor, but we've got like 4 Jenkins servers running, or instances running, because, Team A does releases whenever they need to, and then whenever they want to, and then my team picks it up. We pick it up from different people, and then try to make those available. We've actually opened it up. Our build is available to certain application engineers that want to look at new features. The interesting bit about that is we are really kind of releasing. We're releasing internally, and to maintain a good understanding of what's working and what's not in different releases. That's a communication issue, but yeah.
Yeah, because I like to make sure that leastwise when they're checking something in, they don't break something else.
And I think even in a team of, I think continuous integration is awesome even with a team that isn't delivering to anybody else, just delivering to each other. So that you can know, if I get some weird compiler error, what's going on, but if I look at the build server just built the code and it did fine, so maybe it's something I'm doing. I don't have to yell at the guy next to me.
Right,
So
each developer is going to do the same thing between their stuff. The other thing is, you mentioned about common test tools or common tools. If you have a software team that's developing all their stuff in C++ and C#, how is it, I've been looking into Python, Pytest, and I kind of like what I see with that. But that currently is not a common tool. At least from a development standpoint. I'm not using the same language that my developers are using. I may not be able to use them as resources to help me with my development code.
maybe you should get him to use Pytest.
It would be something worthwhile.
Because I develop in C++ code. That's what we ship, and I like Pytest better. I can for testing. So I get that that's an issue of having the development team use different languages, but Python is pretty darn close to C++ code.
I agree.
And
I like the structure of it. My coworker over here kind of looking at some stuff, and I was looking at Pytest, and it looks like it would be a very useful tool going forward if we can come up with ways of addressing our API.
now, if you're, it's a great test runner also, and the test can be in C or C or C++. There are C++ bindings to Pytest, so it can find. You can have a chain that says run Pytest on C++ code, and it will go and find the tests in certain directories, get it to compile and run tests. It can do those C++ tests and report in the same structure. That's possible, but I get the other way around. But it doesn't make sense to me to have the QA team use a tool that the development team can't run. If you're using different tools, the development team should be able to run the test. Because I don't like it when I get a defect report and I can't reproduce it because it says test 43A failed. I can't run it. So, anybody else?
If someone chooses to not use the mic, we can just repeat the question regardless.
Okay.
I came in here and I was hoping to figure something out about if there's any design for test guidelines. If there's any
Design for test guidelines for software development? What do we want to ask the developers to have in their software, in their user interface or whatever that would allow a software quality engineer to be able to write more effective, more efficient automated tests?
I think that designing for test is difficult because I don't know as a developer how to do what I'm supposed to do different. I thought I was developing for test. And I think more specific questions help. And when I started out, I actually I wasn't being flip when I would say, how do I know it works? And having the development team work with QA to decide, how do I know it works? Sometimes the answer is, you can't. So maybe we should put some hooks in place to find out. There was a interface between a database structure that I was using, even in development, that I wanted to put tests in place that says, even runtime tests, to say this event queue that I'm putting my callbacks into, to say, hey, whenever something happens, call these callbacks. That it was a queue, it had a length, but I couldn't get at it. So I wanted tests in place to say, during my construction time, check the length of those queues. And when I tear myself down during destruction, check those queues also to make sure they're the same as they were before, so that I know I didn't have a resource leak in my layer. And that's a design for test thing as well. And I think design for test is more specific, and that's what getting people involved at the very beginning to say, how do we test this? How do we make sure it works? Exposes those holes in the API. And then often should it be a hidden API? If this feature is important enough to test with, is there a reason to not expose it to the customer? But often there is. Every system I've worked on so far has 2 APIs. There's a debug API that we use for testing. They're not meshed together. It's all these features are customer accessible, and then there's other features that we use to add internal things like queue length and stuff like that to test. And those sorts of bits should be put in place, and there's no reason to not. But it's hard to tell. I've been through meetings to say, hey everybody, we should design for test. I don't know what to do different. So as long as you can be part of the conversation to do something different. Anybody else?
Yes, I saw on one of your slides you said that it's best that developers and QA use the same system, the same test system. I was curious about how you came about that, because I usually, my developers can be somewhat destructive. They're all working on the same system at the same time, where the QA boxes are more clones of what our actual client customers have and are more of a clean environment. So I was wondering where you were coming from, having them both on the same environment.
Oh, I just think they should use the same tools. I think that separation of separating like having a test environment to make it more pristine and clean definitely makes sense. I mean, even in hardware software development, we've got a process where we go through and take, because, okay, so it's not easy to develop on the instruments usually with C++ code. You do the compile, load everything on the box, reboot it, and if you've got debug tags, you got to put those in there, and then there's multiple releases, and there's people who've put like all sorts of junk on there to help out, and it's good to be able to wipe it out. So when we're doing tests for production, we do a different process where we only do release builds and we wipe the hard drive first. That's definitely a good case. My point is, more to the fact that it's not fair to ask a developer to debug a test that he doesn't know how to read, or to debug something that isn't reproducible by the tools that he's used to. It's just an extra burden that I don't think is important. The tools available to run tests that developers need to run are powerful enough for QA teams, and they're not difficult to do. So I don't get why there's a set of tools that we have QA people use and a different set for developers. It's making sure our code works. It's the same problem. Why do we have two solutions for it? That's more of my point.
Do you know about the robot framework for Python?
I'm sorry, could you repeat that?
The robot framework.
Oh, which?
So it's like they use it for test automation and for Python-based test.
Yes, I use Pytest as the test framework for Python.
But you don't know about the robot framework.
The robot framework?
Oh,
Yeah.
robot framework. Yeah. It's cool. And a lot of people, the robot framework is I don't know, for people that aren't familiar with it, I haven't played with it, but it's one of those table-driven sort of things. You fill in lots of numbers to run different things. And for what it is, I think that's neat. I do know that it's not, for one, I'm trying to move, there is this break in Python between 2.7 and 3. So Python 3 has lots more cool features. And I really like all the cool features I get with Python 3. And as far as I know, Robot is still on 2.7 and doesn't support Python 3 yet. And it's also, when it started, it had a customer that was helping to pay for its development. And I don't think that's the case anymore. But I mean, a lot of people still like it. I don't have an opinion other than looks more complicated than I need. The ability to run like a scenario with lots of different data, well, that's cool. And that's one of the reasons why I like Pytest, because it does parameterized testing where I can say, set up this test, but then I've got like maybe even a file full of data that I'm going to throw at it. You can do that with Pytest too. But I don't always need to do that. Sometimes I just need to do something specific. One of the side projects I'm working on needs a database. And I thought, well, that would be a great place to test my theory that I should make the decision late. Which database should I use? And so I'm putting in place, I'm testing with both Mongo and with TinyDB. And they're both similar types of databases. They're document databases. But I can have one set of tests that I run against my software and have a Mongo fixture and a TinyDB fixture, and have Pytest run all the tests with one and then with the other. And I only have to write the test once. So that's one of the things that Robot would give you the ability to like do this, run all these tests on different scenarios. It's cool. The guy that wrote it is a pretty nice guy, but that's really all I got. I haven't used it. So, anybody else used Robot like it? No. Any other questions? Heckling?
One more question. Anyone want it? Please don't forget to fill out the survey. Be greatly appreciated.